Hi and welcome to this nPro tutorial. In this tutorial, I will show you how you can use the new geothermal sizing module in nPro. Let's dive into the software and let's have a look how it works in nPro. So I will create a new example project here. Let's choose a building for this example, but of course it will also work with a district or with the Energy Hub module. And then I click on Create New Project. And this is the example here with a supermarket and a residential zone. So we have one building with some residential area and a supermarket. And I will change just the supermarket a little bit so that we don't have so much cooling here in this example. I will take out the space cooling and the process cooling, say save and close. And then we go to the Energy Hub page, because there we will find the sizing module. So we have this constellation here. We have a geothermal borehole field that supplies the heating demand and also the cooling demand. And we have a heat pump in the geothermal module. And we also have a photovoltaic modules on the roof, for example. I will click on the geothermal settings. Because here we can see that we will use the extraction temperature of 4 degrees Celsius. And this I will discuss it later, because at the end of when we use the sizing module, we will not have this assumption that it's 4 degrees Celsius constant, but that we have a sliding temperature profile, of course. And here for the COP calculation of the heat pump, I will also change this one, and I will use Carnot for the calculation of the COP. So now we will do the sizing of the geothermal field. The first step is actually the power that we need, that we have to take from the ground. These are not really detailed results about the geothermal borehole field, but only the energy that we use or that we need. And now after the simulation, I can click here on geothermal probes, the dimensioning module. And here we can actually define all the parameters in detail. So we can, in the first function here, we can calculate the number of boreholes that we would need. We have different settings for the boreholes, the radius and the resistance. We have some sizing constraints. So for example, what's the depth of the probes, what's the design period, and the temperature constraints. So for example, here we have the minimum inlet temperature at the borehole, which shall not be lower than 0 degrees Celsius. And we have some ground temperatures that we can adjust. On the bottom left, we see the heat extraction. So we take 560 megawatt hours from the ground. And during summer, we have some heat injection. So 32 megawatt hours are going into the ground over the summer. And this is the extraction profile so the heat that comes from the ground or that we inject into the ground. I can now click on calculate, and then we will see how many balls we actually need. So the software gives a proposal here. So one solution would be 9 cross 13 boreholes, so a rectangular form, and this gives us 117 boreholes in total, based on the settings that we have. So we have assumed 150 meters of depth, and we shall not have lower than 0 degrees Celsius. And in this case, we have 0.2 degrees Celsius as a result. We can now use the other function. For example, we could also calculate the probe length for a given borehole arrangement, or we can calculate the fluid temperature based on the arrangement and on the length of the boreholes. And the last function here, temperature profiles, can be used to calculate the seasonal profile of the temperatures. And so I click on recalculate, and if we scroll a little bit down then, the results, we will find the profiles for the temperatures. So here on the bottom left, we see the temperatures at the borehole inlet and outlet. And over the entire year of the design year, so year 50 in this example, And here we see the minimum and the maximum temperature at the borehole inlet and outlet over these 15 design periods. And so at the beginning, I said that we used for the geothermal calculation like 4 degrees Celsius for the heat extraction temperature. And of course, that's not true as we see. So in winter, we have a lower temperature. It's lower than 4 degrees Celsius. And in summer, it's higher than 4 degrees Celsius. And we can now use in an iterative approach, we can now use this profile here, this temperature profile, to refine our calculation. So we can click on this button, which says use extraction temperature profile in geothermal energy settings. We can click on it, and then it opens up the geothermal settings as we saw it before already. And here under extraction temperature, we had these 4 degrees Celsius as a constant before. And now we just using these profiles that we calculated to make a more detailed calculation. So now we are using a temperature that is between 3.3 and 8.1 degrees Celsius for the extraction temperature. And as a result, the COP also changes over the season. So in winter, we have a COP of around about 4.9 degrees, 4.9. And in summer, we have a COP of 5.7. So with these settings, we could now go again into the sizing calculation and see how does this change the sizing of the geothermal probes. And here we can see due to the changed COP, this extraction power also changes from 319 to 317. Not a large difference, but at least a little bit. And then when we go into the simulation again, we can then also see, okay, what is the detailed calculation based on this seasonal COP profile? How does this change the results? One last remark about the geothermal sizing module. We can also download the results as Excel sheet and then compare different solutions with each other and compare different borehole arrangements, for example. If you would like to learn more about the module and how the calculation is done, you can click here on documentation. And on the documentation page, you find some introduction and some explanation, and also the detailed methods. So what did we use to calculate, for example, the G function, and how is the calculation done in detail. We also validated this module with two software, with two other softwares. That's EED as Energy Designer, very well-known tool for calculating geothermal borehole fields. We have a slight deviation here that comes mainly from the calculation of the G function. So for example, in this case, we are 1.4% off compared to EED. But of course, like if you compare it to the uncertainty that you have in the input parameters, I think that's an acceptable range. We also compared it with Geothermal software, German software that also is able to calculate geothermal borehole arrangements. And here on the bottom of the page, you find some more information also about input parameters. So if you are unsure where to get different parameter settings of the values of the parameters, then you can have a look here, because there are some resources where you can find typical values for the input parameters. All right, thank you very much for your attention. I hope that it helped you a little bit to have an introduction how to use this geothermal borehole sizing module in nPro. If you have questions or comments, please just use the comment box below the video. And thank you very much for your attention, and see you next time.